Just take a look around you for a second. I bet you're surrounded by it. It's in our walls, the sidewalks we walk on, the massive skyscrapers that make up our cities. Yeah, I'm talking about concrete. It's literally the second most used substance on Earth, right after water. But it comes with this enormous hidden cost. So what is it? Let's get into it.
Yeah, you heard that right. 7 to 8%. The production of cement, which is, the key ingredient that holds concrete together, is responsible for that huge chunk of all global CO2 emissions. To put that in perspective, that's more than the entire airline industry combined. This one material, the very foundation of our modern world, is also a massive driver of climate change.
So that raises a pretty big question, doesn't it? If we want to build a more sustainable future, do we actually have to reinvent the very bricks and blocks we use to build it with? Well, a lot of researchers think the answer is a big yes. And the solution they found is, well, it's pretty incredible.
Okay, so what makes regular old cement so dirty? The problem is really how we make the most common type, which is called Portland cement. You have to take limestone and cook it in these gigantic kilns at ridiculously high temperatures. Now, not only does that process use a ton of energy, but it also releases huge amounts of stored carbon dioxide straight into the atmosphere.
But what if we could make a concrete-like binder without all that crazy heat? Well, that's where the hero of our story comes in, geopolymers. And trust me, these are a seriously promising alternative that could completely change the game for construction.
So what the heck is a geopolymer? The simplest way to think about it is like a new kind of superglue for building materials. It's made by chemically waking up materials that are already full of silicon and alumina. And here is the absolute game changer. The whole process can happen at room temperature. No giant carbon-spewing kilns needed at all.
I mean, when you put them side by side, the difference is it's night and day. On one hand, you've got Portland cement. Super high temperatures, burns through energy, and pumps out massive emissions. And on the other hand, you have geopolymers. Room temperature process, low energy, and a radically lower carbon footprint. It's not even a fair fight.
So how do you actually cook up one of these amazing new bricks? Well, the recent study came up with a really interesting recipe, one that combines two pretty common and fascinating materials. Let's take a look at the ingredient list.
On the left, we've got metakaolin. Sounds complicated, but it's basically a type of clay that's been treated to be extra reactive. And on the right, basalt, which is really just finely ground up volcanic rock. The whole idea here is to combine the best properties of both of these to create something totally new and much stronger.
And you can see right here why they make such a great team. The metakaolin is an absolute powerhouse of silica and alumina. Those are the essential ingredients for the geopolymer reaction to even happen. Then the basalt comes in and adds things like iron and calcium oxides, which act like reinforcements to give the final product a big boost in strength and toughness.
Now, to find that perfect sweet spot, the researchers mixed up 3 different batches. They made one that was 70% metakaolin and 30% basalt, another that was 60-40, and a final one that was a 50-50 split. Then it was time to put these new blocks through some serious stress tests. And so welcome to the ultimate block bake-off. Which one of our 3 recipes is going to come out on top? Which one is the most durable, the densest, and the strongest? Let's check out the results.
Okay, first up, the water absorption test. Now, for any good building material, you want this number to be as low as possible. Less water soaking in means less damage and a building that lasts way longer. And right away, we have a clear winner. The 50-50 mix, the one with the most basalt, absorbed the least amount of water.
Next test is bulk density. Here, higher is better. A denser block is more compact, it has fewer little gaps inside, and that usually means it's going to be stronger. And look at that. Once again, the 50-50 mix comes out on top, being the densest of the bunch. So far, it's looking like a clean sweep.
And now for the main event, compressive strength. This is the big one. It's all about how much pressure you can put on the block before it cracks and breaks. And for the 3rd time in a row, the 50-50 mix absolutely crushes the competition. It topped out at an impressive 19.6 megapascals. It's the strongest by far. So, the winner seems pretty obvious, right? I mean, the 50-50 block dominated every single test. But in the world of material science, the whole story is rarely just about the numbers on a chart. And this time, there's a pretty big twist.
So based on everything we've seen, you'd think the 50-50 mix is the no-brainer choice. But to find the real champion, the researchers had to look deeper. And I mean,
literally deeper. So they pulled out a powerful scanning electron microscope to look at the internal structure of these blocks, and what they found was really surprising. While the 50-50 mix was the strongest on paper, its insides weren't as evenly mixed. It was actually the runner-up, the 60-40 mix, that had the most uniform and densely packed microstructure. Think of it like a solid, perfectly built wall versus one that has some hidden tiny gaps in it. That uniformity is absolutely critical for long-term durability.
And, the researchers themselves said it best. They concluded that the 60-40 blend offers the optimal balance. It wasn't just about being the strongest in a quick lab test. It was about having the best overall combination of strength, durability, and a solid internal structure that's built to last in the real world.
So, what are the big takeaways here? First, that these eco-friendly geopolymers are a totally viable, powerful alternative to traditional cement. Second, adding a filler like basalt powder is a fantastic way to boost their performance. And maybe the most important lesson of all, the best recipe isn't always the one that's the strongest. The real prize is finding that perfect, optimal balance for long-term durability.
It's just a powerful reminder that sometimes, to solve our biggest challenges, we have to look at things a little differently, sometimes even under a microscope. And it really makes you wonder, right? If we can totally reinvent something as ancient and as basic as the brick, what else can we reinvent?